Is there supposed to be audio?
Okay, there we go.
Can you hear me now?
There we go.
Testing, 1, 2, 3. Can you hear me? That's not looking good.
That bodes poorly. Can folks in
Yeah,
the
I
Zoom?
can hear you.
Okay.
All right.
Okay.
Okay. So starting from the top. Okay. Hello, my name is Sam Falvo.
Did you guys hear that part? Okay, on with the show. You're Sam.
Okay, so I'm Sam Falvo. Last month I gave a talk that was probably 6 months in the making about a project that I'm working on called Fourth Box 20th Anniversary Edition. If you want a quick recap on that, I encourage you to check out the SVFig archives. During that talk, though, there was a particular point where I wanted to give a quick demo of what I was working on, and it failed spectacularly to the point where the only thing that I could say was reliably working was the OK prompt. I've made some changes since then. Things seem to be working better now. It is still woefully incomplete as a fourth environment, but I just wanted to take this opportunity to kind of give the demo that I wanted to give last month and hopefully walk through some of the code that allows that to happen. And I'm kind of glad that we have some fourth implementers here too, because I have some questions that I want to ask of them later on after this presentation. So the first thing I'm going to do is go to my Fourth Box project. If this doesn't make any sense, that's okay. It's not really intended to. But let's start off with a quick demo. So the first thing that is coming up here, so this region of the display is a bitmapped frame buffer, which I'm not currently using. It does work. I've tested it in the past, but it's irrelevant for our needs right now. This is kind of a machine language monitor. If you've ever used a Kim1 or a Commodore PET or a Commodore 128 and you've typed in monitor and you get the interactive monitor, this is almost an almost exact clone of the original TIM monitor from 1977 for the 6502. It has been ported by me to the 65816. So this is a 16-bit variant of the 6502. That's why all the registers are 16 bits wide now. So what I'm doing now is I'm changing the program counter. My computer is a little bit laggy at the moment for some reason. Changing the program counter to the start address. And if I tell it to go, it comes up with System Force version 0.2 this time. This is actually wrong. It's actually 0.3. But check this out. So if I do a 128 load, it actually works. So I managed to get that working. And basically, I finally have a list implementation. And because of my font size, let me get rid of that there. Basically, it's intended that 128 is the startup block. So every time you boot into the system, this block will automatically get loaded. That's the idea. It doesn't do that right now, but eventually, in a couple of months, maybe years, we'll see what happens. And you'll notice that one of the things that I'm loading here is cursor positioning. And actually, before that, I have to tell Forth what a comment is, because I forgot to tell it that. But I figured this would be a good place to demonstrate that colon compiler actually works and does support immediate words, which is nice. So eventually that will be integrated into the actual core of the compiler. And so this is a very simple set of words. I originally just wanted it to, define the word page to clear the screen and at XY to position the cursor. And then I realized that homing and clearing the screen separately as separate items is unto themselves useful. So I kind of factored those out. But the nice thing that I really wanted to show last month was kind of a simple tic-tac-toe sort of game, sort of thing. And so I have this code that I wrote that doesn't really implement, you're not like playing against the computer, but it does implement a good portion of that, of the logic needed to play the game. And so that's what I wanted to demonstrate today. And this is one of the questions that I have, which is, gosh, this is taking an awful long time to compile, even though I've implemented hashed word lists. I'm not sure why, but at least it works. I'm happy. So if we start, you can see that it produces a tic-tac-toe grid, and at this point you can actually use words to actually deposit tokens, X and O tokens. And if we do, looks like X is in trouble. Shucky darn. Now it looks like, and so on and so forth. So we all know pretty much how this is going to go. If you decide to type in a word or a location that's already occupied, it says you can't go there. Obviously, it makes sense. And then that's a draw. But then you can end the game, or you can. So now, if I type in a location, game sessions, not in session. And so basically, this is all maintained in a set of variables. The XOS, that's XOs in plural, basically this forms a simple array of 3 variables, one for each row of the basically one for each row of the grid here. Oops. And so I've got little accessors there to make referencing the individual rows easier. Unfortunately, I don't have create implemented yet, so I can't do a proper, create XOS and then, a number of a lot to reserve space. So basically, just doing things very, very simply, very brutally simple at the moment. This is the paint logic. It is not the easiest code to understand, as you can imagine, because it's packed inside of a single block. But there's also a couple of things that I'm still trying to figure out. So for example, you'll notice that I've got a row fetched and a dot followed by a space. That's intended to print a number, right? But if I do a paint, there are no numbers. I don't know why. However, if I do this, there's a number. So why does it work interactively but not in a colon definition, right? Normally you would expect the opposite. It works in a colon definition but not interactively because you're overwriting some buffer somewhere, right? So I'm not sure why this is happening. So this is some of the curious issues that I'm running into while I'm trying to develop System Forth into a working system. All total, if I were to load this again,
surprisingly slow.
It is very surprisingly so. Somehow I ended up with 26K. That's not right. I know that's not right. Because that number is not big enough. Which means that there must be garbage on the stack somewhere. I'll do this the manual way. Okay. So basically a little shy of 1,200 bytes for the tic-tac-toe demo. The fourth environment is a subroutine threaded fourth environment, actually, which is probably the first time I've ever designed such a thing. If I want to exit, it drops me back into the machine language monitor. So that's kind of the demo that I wanted to give last month, along with some of the illustrations of the issues that I was having implementing it.
Is it 16 bit?
It is 16
Okay,
bit.
well, that was probably why you subtracted the bigger from the small.
Yeah. Yeah. So and for some reason,
So no, you didn't. You had the swap. Okay,
Yeah.
I don't get it.
I did have, yeah. So again,
Swap's broken.
but it's not, because if it was, tic-tac-toe wouldn't work, right?
Weird.
So again, I'm not sure what's happening. There's an awful lot of black magic and voodoo that's happening in here, and I'm not quite sure why things are not working. Tested in isolation, things work fine. But when I build it up into a bigger system, that's when things start interacting in strange ways. So this is a kind of a rough approximation of how big the source code is. We see, some of the things are as small as 188 bytes. And I think the largest thing that we have is about 10K, and that's an assembly language file. So if we look at the colon compiler, for example, you'll notice, and this is pretty much true of anything, you'll notice that all my colon definitions are either TX or T colon, right? You're probably wondering why that is. Well, if you watched the presentation from last month, you would know, but I'll recap it here. This dialect of fourth, quote unquote, is something I call shoehorn. It is a bootstrap compiler. It is intended specifically to let me bring up or to write a large body of code, such as System Fourth, and to port it to a new processor architecture from scratch in a matter of days to weeks. The idea of spending man weeks to man months or even man years porting a compiler, which is something that I personally observed in the RISC-V community, is absolutely anathema to me. Now, to be fair, this compiler does not optimize at all. It is woefully inefficient in terms of how it uses memory, but that's okay. That's not its form. That's not its purpose. Its purpose is to just get something running. Make that LED blink. I don't care, right? So that's how shoehorn is. Or I should say, this is what shoehorn code actually looks like, and it is actually a dialect, a true dialect of fourth. As you can see, the definition of the right bracket, that's fourth, right? What it looks like when it compiles is something like this. As you can see, that's what subroutine threaded fourth looks like, right? Just a bunch of subroutine calls and every now and again an inline constant. And that's where, and those data structures there, that's the dictionary structure. Now, one of the reasons why I wanted to have shoehorn compile to an assembly listing instead of just compiling it straight into object code is because a lot of times there's useful libraries that are already in assembly language format, and you just want to be able to integrate that as is. For example, the 65816 lacks multiply routines or divide routines, or multiply and divide instructions. But there are plenty of examples of how to do this in subroutine form on the web. So instead of having to go through and write my own assembler on top of all this other stuff, I figured let's just emit assembly code and I'll just assemble it and link it manually from there. And yeah, as you can see, that turns out to work. That part works. Yes, go ahead.
That's a cool idea. It's just like an include.
Yeah, exactly. Yeah, the comment was that it was a nice idea and that it was essentially just an include. That's the point. Just to be able to just, get it done. Yes.
I don't remember from the last presentation, but this is 65816 code. Are you running it under an emulator here, or do you have okay?
Yeah,